mathematics, we got so many 3D shapes all along with their characteristic of area and volume. But do you know how to find the volume of this object? Or this object? Or this? All of those solids are not the same as any other solids. It is non-basic. It's not cube, neither a cylinder, nor a cone. But those solids actually have one thing in common. Now, take a look at this thing, pottery. Do you know how it is made? Yeah, using the tools underneath it which spins around and help the potter to mold the pottery. Basically, the solid was made by the circular motion or what's so called as revolution. The revolution has made the solid have a rotational symmetry. It will look the same even after some rotation. See? Since these objects are made by spinning motion or revolution, this object is later going to be called as solids of revolution. So, how can we find the volume of solids of revolution without having the exact formula on that? Chill. Mathematics is all about problem solving, and this problem is going to be solved by one of the idea underneath the calculus topic, which is integral. Curious enough?
To understand the use of integral in finding the volume of solid of revolution, we are gonna use the idea of definite integral, which is finding the area underneath the graph by adding the infinitesimals rectangles in it. There are actually two methods to find the volume of solids of revolution by integral, which is this and shell method. But today we are not gonna talk about this method, but shell method. So, what is the exact shell method? For the formal definition of shell method, is a method of finding volumes by decomposing a solid of revolution into cylindrical shells, which will look like this. So, let's say that we need to take out a slice from this shape, and how do we get it out? Where does the tubes comes from? Then from this picture, you must have noticed that this shape is a rectangle, but it becomes a tube when we rotating it by y-axis. And to get the slice, we need to cut it to the x-axis and do it with this portion. So, when we rotate it around, it will be a shell. To find the exact volume of the solid, we will add all of those cells from a point to another point, which is the exact concept of definite integral or the summation.
So how are we gonna find the volume of the solid using integrals? As said before, the shell method finds the volume of a solid revolution by summing a set of hollow cylinders. Now, we first consider the simple case of a cone, so that we can easily find the formula. We use a set of cookie cutters to slice the cylinder into a set of hollow cylinders. If we take it out, here are the individual shells of it. What are we gonna do next is to find the volume of the individual cylinder, which later on will be summed by integration. To make it easier finding the volume of a cylinder, we're gonna cut it vertically and lay it out flat. Here, we will find that the cylinders are actually a rectangular frames. Then, the cylinder volume will also be equal to rectangular frames volume. As we know, the volume of a rectangular prism will be length times width times height. What do you think the length of this rectangular prism be? Yep, the length will be the circumference of the cylinder, which is 2 pi r. But the question is, what is the r? Take a look at this graph and I will draw the line through the r. Yes, the r can be represented by the x in this plane. So the length will be 2 pi x. Then for the height, if we notice that the height of this cylinder is made from the function, or it will be equal to y or fx, so the height will be fx. As for the width, it is the thickness of the shell. But what is it? Now take a look at this 2D plan. Before the infinite small rectangle or being rotates through the y-axis, we know that the thickness of the cylinder is actually the part right here. It is the change of x, which is almost zero, or so-called as dx. So the width will be dx. Now the formula of one cylinder is complete. It is yes, it is 2 pi x fx dx. This is the formula that we're gonna add using integral. Creating the formula of shell method, which is v is equal to integral from a to b to v x fx dx, or mostly written as this. So from here, we can know the formula of the solid revolution.
So, this is the application in problem of the shell method. A solid is generated by revolving the region bounded by y equals to square root of 9 minus x squared and y equals to 0 about the y-axis. A hole centered along the axis of revolution is drilled through the solid so that 1/3 of the volume is removed. So find the diameter of the hole. So to solve the problem, first we need to get volume of the hemisphere or volume without hole that is created by rotating the region. We will rotate just half of the semicircle and integrate with respect to x using the shell method. And the result as seen in the picture is 18p. After find the volume without hole or the volume of the hemisphere, we can easily find the volume of hole since we know that it is 1/3 the volume of hemisphere. So we get the volume of hole is 1/3 multiplied with 18p equals to 6p. Now we must find the diameter of the hole. D equals to 2r such that 6p equals to 2p integral from 0 to r multiply x multiply fx dx. And then we get the r is equal to square root of 9 minus 18 to the power 3/2. And we can substitute r in d equals 2 multiply with r. And we get the result of the diameter of hole is 2.92.
Thanks for watching! We hope you understand more about the shell method concept through this video. Don't forget to like, comment, and subscribe. Bye bye! See you again!